Oh, happy day. All right. 7.5 surface area of prisms. Okay, this could be one of the more challenging, one of the most challenging sections. So I want you to pause the video, go get a drink, come back when you're ready, take some notes. Definitely want to be thinking and listening carefully to this video. Okay, so in surface area of prisms, okay, we'll get into it, but we're going to learn what nets are. We're going to learn, I don't really use nets personally, but if you give me a net, I will gladly use it, and we'll talk about that in a second. We're going to use, we're going to figure out how to find the surface area of prisms, okay? So the success criteria, not as important here. Okay, so let's talk about this. What is the surface area? So think of the surface area of an object as what you would paint, okay? So the two things we're going to learn in this chapter still are surface area and volume. So I always think of it as if this is my three-dimensional object, okay? The surface area is how much paint. Like, so what in a real world scenario, I would need to know the surface area, so I would know how many square feet or inches or whatever that I needed to paint. So surface area, think painting the outside. Okay, whereas volume would be think about filling it full, filling it up with water. Okay, so pouring water into this three-dimensional shape would be the volume. So we're going to be talking about surface area, so painting these sections. So they're going to use different colors, they're going to show us some things, and we're going to learn it, okay? So you can use a two-dimensional representation of a solid called a net. Okay, so the net is this thing right here. Okay, and where a net is important is if you want to be a box maker, okay, someday, this is how you would produce them, okay? You would have this big piece of cardboard, and you would cut it into this shape down here, and then it would be folded. It would be folded up. So if you want to make a box, you need to understand nets, okay? If I'm given a net, it makes it easy to find the surface area because all I have to do is find the area of this thing, this thing, this thing, this thing, this thing, and this thing, and I've got the whole surface area by adding them up. So if this one is 5, and this one is 4, and this one is 6, and 6, then this one would be 5, and this one would be 4. Well, I just add 5 plus 4 plus 6 plus 6 plus 5 plus 4, and I've got the surface area. That's super easy. The thing is in geometry, they're generally just going to give you this thing right here and ask you to figure it out. So if this unfolding thing, you almost want to pause the video and look at it, okay, to see how they made this look like this, okay? Pause the video. This actually is a really good graphic of how to unfold and how to make that, okay? But I'm going to tell you right now, so hopefully you're back from pausing the video and looking at this folding technique. I do not convert this to this. I personally do not. If you like this, there's some Khan Academy videos that are great. That I plan to post, if I remember. I plan to post them for you guys in Google Classroom. That if you want to learn this net style, okay. I find that I make mistakes. I forget sides sometimes when I do it, so I just kind of look at it. I look at this and I realize that this green here has a back side to it. So whatever this green is, there's another green. In fact, let me just draw that for you, that there's another green, right, that's back here, that's the same, okay? And I can, from my brain, it works very well to be able to look at a solid and kind of picture it. So however you want to do it, I'm going to teach it kind of without this because I'm telling you, I make mistakes when I try to make the nets. I always make mistakes. So let's look at how they do one, and then what we're gonna do is we're gonna look at the surface area of a rectangular prism, and we're gonna look at the surface area of a triangular prism, and we're gonna see how they did it, and then we're gonna do it ourselves. Okay, so let's look at this. All right, so they color coded it and everything. All right, so let's look at this. So the base of this is red. Okay, so this is the base. Okay, and it has its counterpart, which is this bottom part, and this is how I think about it. So you can look at the top and bottom of the net. Okay, they've unfolded it. I personally just think of top and bottom are going to be the same, and they are both length. So what is the formula for that? Well, it's length times width, right? The area of a rectangle is length times width. So we have 7 times 4. 7 times 4. Okay? So that's how they figured that out. And then the front and back. Okay, so again, this is how I think about it. So we have the front is already green, and the back is back here. Right, that part right there, okay, that's on the back side of this, right? So these lines still exist, but it is in the back, okay? And so this length and this length are the same, right? So this back here is the same as this, and then the width is this line right here, right? Which corresponds to this side over here, which is 3. Right, so length times width, 7 times 3. So the green is 7 times 3, or 21. Okay, and so with the surface area of the whole thing, let's look at that for a second. The surface area of the whole thing is simply the area of all of these things, right? So this, and these two are the same. We've already done those, right? So 28. Another way to look at it is times 2. Instead of so we could have 28 times 2 plus 21 times 2 so far. And then we're going to look at the blue, which is this side over here and this side over here. And we have the length. Let's go black here. We have this bottom part is the length, which is so length times width. We have 4 is our length. And then let's call this our width, which is the same as this, which is 3. So 4 times 3, notice here, that's what they have, is 12, okay? So then we would have plus 12 times 2, because there's 2 12s, right? So then we add that up and we get 122. Okay, so moving on. Let's look at a triangular prism, okay? So a triangular prism is called that because, remember, a prism has 2 bases, okay, and it has its lateral faces are parallelograms, okay? So these are the parallelograms are all going to be length times width. But in this case, it's a triangle. So if you look at this, my base, I like my bases to be red. My base is this green here, okay? And it's got its other friend over here, which is in the back, okay? And so it does have its 2 bases, and its lateral fronts, in other words, this orange and this blue, are parallelograms. Okay, now they are not the same. Notice that these are different colors, and notice that when they unfolded this, okay, that this is that this side is bigger. Okay, so we would have known that if they gave us side lengths. Like if they would have made that 6 and that 5, we would have been like, oh, this is a different size, okay? And the reason being is because this here is not a, these have different lengths. So this hypotenuse here is longer than this side, for instance, okay? So too much information, sorry. Okay, so pause the video, look at the fold. If you want to see how the net works, notice, so hopefully you paused it, looked at it, notice that this is the bottom, but our bases are these two green triangles. Okay, this was the bottom, the front folded out, the back folded out, and we're good. Okay, so let's see how they find the surface area. Okay, so again, the surface area is just the area of this plus this plus this plus this plus this. Okay, so we have to find the area of this, of our bases first. Actually, they find the area of the bottom first. So the bottom is this thing. So the bottom, I call this my launch ramp. So if I was a skateboarder, so I would ramp off the top of that. Fun. Okay, so the bottom is this. So it is length times width. It's a rectangle. So we have the length of 12 and the width of 8, right? So 12 times 8 is 96, and there's our 96. And I'm going to tell you right now, we are not going to do the other two examples. I'm just doing these two slowly. But hopefully this will help you. Okay. And now we're going to do our triangles, which is our bases. I usually would start with the base, but whatever. Okay, and so the area of a triangle is 1/2 base times height. So area equals 1/2, that's part of it. The base is this part, which is 12. And the height is always, you always want to look for this little right angle to know where the height is. So there's my height. And it is the same as this part, right, over here. So it's 5. So 1/2 of 12 is 6. 6 times 5 is 30, right? So we have 30, but we have two different bases. So I'm going to multiply that by 2. So 96 plus 30 times 2, okay? And now we've got to figure out this guy. Well, this is 13, okay? So we're doing the blue part now. So this here is a length of 13. Here, let me erase everything else. Okay, we have a length of 13 and a width of, well, that's the same as this down here. So that would be 8. So 13 times 8 is 104. So that's the area of this blue side, okay? And then we've got this area of this smaller thing, which is our back side, just the back of the ramp. And it is length times width. So 8 times 5, and we've got our 8 times 5, and that's 40. We add all of these up. 96 plus 30 times 2 plus 104 plus 40, and we get 300. Okay? It is it's just a lot of work for one problem, but that's why if you look at your homework, you did not, I think I assigned less than 10, okay? I think it was 7 or 8, but I don't want to say that for sure. But I won't assign a ton of these, but just take your time and think about these, okay? So hopefully that last lesson really helped you with that. Okay, so let's just look at this, okay? So we've got a front and a back that are the same, right? And they are length 9, width 5. So it'd be 9 times 5, and then there's 2 of them, right? So times 2. And then we have the front and the back. We have the top, which is this part, and the bottom. Sorry, I'm going really fast here. And the bottom. So this was the front and the back. This is the top and the bottom. The top and the bottom would be, so the top and the bottom would be something like length times width, right? But so that'd be 9, and then that corresponds to this. So it'd be 9 times let's see. Did we mess that up? 9 times, yes, 9 times. On this one up here, we should have corresponded with this would be 6. So we should have had 9 times 6. This one here is 9 times, the top and the bottom is 9 by, wait, top and bottom, no, top, okay, I had it right to begin with. Top and bottom are 9 times 6. Let's slow down if we're going to do this. Okay, so 9, so we're doing top and bottom. So that's this right here. They're the same. And it is 9 by 6. 9 times 6. And then there's 2 of those. I've got this, and I've got this top part. So there's 2 of those. And then lastly, I've got my sides, right? So my sides are there and over here. And they are also the same, okay? And they are 6 by 5. So sides, say equal, 6 times 5, and there's 2 of those. So then you would multiply those together and add them up, right? So 9 times 5 is 45, times 2 is 90. 9 times 6 is 54. 54 times 2 is 108. 6 times 5 is 30, times 2 is 60, and then we add these all up. Okay, I'm done, because I want to look at this one too. Okay, so now, in this one here, we have the front and the back of this shape, and they're both triangles, so they're both 1/2 base times height, right? Base of 4, height of 3, 1/2 times 4 times 3. So that's going to give us that, and there's 2 of those. Okay, so 1/2 base times height, and then we're going to multiply this, and then there's 2 of those. Okay, so that's the front and back. And then we've got the bottom is separate. Okay, so we need to figure out length times width of that. And then we have the kind of the front, or if this was my launch ramp, the part that you launch off of, which is this guy. Okay, and it is 5 by 4. And then lastly, we have this back part. Okay, this back part back here, which looks like 4 by 3. Okay, and there's only one of each of those. So then you would multiply and add all those up. So hopefully I didn't go too fast through that. We want to go through the cube here really quick. So this video's gotten away from me and it's a little long. I apologize, but it's important. Okay, so a cube. Okay, a cube has. So think of a cube as a die, like a rolling a dice. How many sides are there? There's 6, right? So that's where the 6 comes in. All the sides are equal in a cube. All the sides are equal, so therefore you take the 6 times the side length. Let's say that this side length was 3, okay? So then you would take the surface area would be 6 times 3 squared. 3 squared is 9. 9 times 6 is 54. So that would be 54. Okay, and they do the same thing down here in this example. You can pause and look at this cube down here and how they did it. Pause it right now. Look at the cube. They work it out for you. All right, that'll do it.